In this video, I'm going to show you how to solve the ALEKS problem called interconverting the amount of radioactive decay and half-life. There's two equations that we're going to use to solve this problem. The first equation is the natural log of the amount of nuclide at time t over the initial amount of nuclide is equal to negative k, the rate constant, times t, the time. We're also going to use the equation for solving the half-life. T1/2 is 0.693 over k. So this particular problem gives us two amounts of our nuclides. It says the sample is decaying from 2.2 milligrams. That's going to be our n at initial time, n at time equals 0. And then 200 micrograms, that's going to be our n sub t. And then it's giving us 3.09 times 10 to the third years. That's our time. That's not our half-life. That's just the amount of time that it takes for this decay to take place. We're going to plug these three numbers into this equation right here and solve for the rate constant k. And then once we know the rate constant, we can plug it into this equation and solve for the half-life, T1/2. We've got to be a little bit careful here because we have different units in our nuclide quantities. We have 2.2 milligrams, and then we also have 200 micrograms. So we want to make sure that they have the same unit. And it doesn't matter which unit they have. We could convert them to micrograms. We could convert them to milligrams, as long as the unit is the same. Maybe an easier way to do this would be to convert both of them to grams. That's what I'm going to do for this problem. I'm going to convert my milligrams to grams. Milli is the prefix for 10 to the minus 3. That means 1 milli is 10 to the minus 3 grams, and this is going to give me 2.20 times 10 to the minus 3 grams. And then I'm going to do the same conversion for my microgram. 200 microgram multiply by a conversion factor with microgram on the bottom, gram on top. Micro is 10 to the minus 6. That means 1 micro is 10 to the minus 6 grams. 200 times 10 to the minus 6 grams. And again, as far as this step is concerned, all that really matters is that both of these are in the same unit. It could be any unit you want. They just need to be the same. So let's plug in what we have into our natural log equation. Our n at time t was the 200 micrograms. So that's this one right here. This is our n at time t. 200 times 10 to the negative 6. That's a gram. And then our initial amount was 2.2 times 10 to the minus 3. We can leave the units off of this because the units are just going to end up canceling each other out. Negative k, so k is the variable that we're trying to solve for in this problem. We don't know what k is, so I'm just going to leave that as k. And then our time is 3.09 times 10 to the third years. And I'll begin by solving the stuff on the left-hand side, the natural log. 200 times 10 to the minus 6 divided by 2.2 times 10 to the minus 3, and take the natural log of that, and I get negative 2.398, and that is equal to negative k 3.09 times 10 to the third years. And now we can solve for the rate constant k. Our rate constant is 7.76 times 10 to the negative 4, and its unit is inverse years. Now that we know k, we can plug a k into the equation to calculate our half-life. I'm going to do that in a different color. Our half-life is 0.693. We're going to divide that by the rate constant, 7.76 times 10 to the minus 4, inverse years. And that gives us a half-life of 893 years. ALEKS wants this to two significant figures, so we're going to go 8.9 times 10 to the 2.